Alright folks, this is your test corrections for LearnCheck number 12. We're looking at angle of elevation and depression. Alright, number 1. So imagine being at a concert, your favorite artist is standing up on a stage, and you are on the ground. So let's pause right there. Let's come up with a little picture. So ground, here you are, and there's some sort of stage. And the artist is up here. All right, it says that the angle of depression from the artist on the stage to you is 10 degrees. So, angle of depression. Remember that an angle of depression starts with a horizontal line. So if you can imagine, the artist was looking straight ahead. But then they're going to tilt their head down 10 degrees to look at you. So this person standing here, we're starting to see this triangle form. So we should be able to see like them standing here. This is a right triangle, the ground, and again, when they look down, that is this diagonal line. So notice that the 10 degrees is on the outside of this triangle right now. Okay, so then it says if you are standing 50 feet away, so 50 feet away from the base of the stage, so here would be the base would be at the bottom to where you are, so this is 50 feet. What is the height of the stage to the nearest foot? So we want to know the stage here, and really I guess our triangle should end at this corner, but I made it up to the person. So we're going to be solving for this side right here. Okay, so there are a couple ways to solve this, but for me personally, I normally just draw a second triangle. If this is 50, then the top is also 50, and if we're solving for this side, then this side can also be our x. We do have a theta, so theta opposite hypotenuse, that means 50 is our adjacent. Again, let's think about what we are given, what we need to solve for. So we are given the 50, which is our adjacent. We're given theta. We need to solve for the opposite, so it means we don't need the hypotenuse here. So which trig ratio is A and O? Well, that would be tangent. So tangent of theta is equal to O over A. Tangent of 10 degrees is equal to O, which is our x, we don't know what that is, and our A, which is 50. All right, we need to get x by itself. We also need to get rid of this fraction. So my denominator is 50, so times 50 times 50. Now that we have x by itself, it is time for Desmos. So 50 times tangent of 10 degrees. And again, we're going to make sure that we are in degree mode. So we get 8.8. And if we want to round it to the nearest foot, then that would be 9 feet is the stage. And so that was answer choice B right here. All right, let's go on to the next question. All right, the men's basketball team is working out by running up the staircase of the stadium. So if you can imagine this, here's our men's basketball team. And if you can imagine, oh, that's a horrible staircase, but staircase of some sort of stadium that they're going to be running up. Okay, then it says from the ground to the highest, or the tallest row of seats. So from the ground up to the highest row of seats, the stadium is 48 feet tall. One of the players is standing at the bottom of the stairs and measures the angle from his feet up to the top of the stadium to be around 12 degrees. So from here all the way up to the top, that would be, again, 12 degrees. What is the diagonal distance from the base of the stairs to the top of the stadium and then back down to the bottom of the stairs? So x. All right, so with this information, we know that 12 is our theta, and this is going to be our opposite. Oh, we forgot to label. So obviously from the top to the ground, this would be 90 degrees. So that means that x is our hypotenuse. And then the ground part here is our adjacent, it's our leftover side. All right, so what are we given? What do we need to solve for? Given theta, given the opposite, we need to solve for the hypotenuse. We do not need the adjacent side. So which trig ratio is O and H? That would be sine. So sine of theta is equal to our O over our H. Again, we need to get rid of this denominator. So times x times x. So 48 is equal to x times sine of 12 divided by sine of 12. X is equal to, so with this, we are going to be putting this into our calculator. So let's pull up Desmos. So 48 divided by sine of 12. So we get 230.87. Now this is a little tricky. Let's look back at this question. We want to know the horizontal distance from the base of the stairs to the top of the stadium and then back down to the bottom of the stairs. So if we go up and it's 230.8 or 230.87 and then we go back down again, this needs to be doubled. So either times 2 or just double it. So when we do this, this is going to be, let's bring up, so we can just go ahead and multiply times 2, so 230.87 times 2. And so that's 461.74, which is approximately 462 feet. Now, if you put the 231, you are correct. You just missed that issue there of all the way up and then back down again. You forgot to double. Okay? All right, let's move on to another problem. All right, a pilot begins making calculations to land his plane. So that means his plane is up in the air. So you could draw a plane, or you could just write the word plane. And the pilot was, of course, moving straight ahead, but they're going to be working on landing their plane. Okay, the current altitude, remember altitude means height, is 15,400 feet above the ground. So if we've got the ground, so it means the plane from up in the air to the ground, again, is 15,400. And then it says the plane's horizontal distance to Charlotte Douglas International Airport is 200,000 feet away. So this horizontal distance, that's important to us because horizontal is a flat line. So it's saying pretty much like along the ground where the plane is, if you were to draw up a pen, from where the plane is all the way to where the airport is. So again, Charlotte Douglas International, that distance is the 200,000 feet. So then it says, what angle of depression must the pilot make on his descent in order to safely land on the runway? So like the runway would start like right here, you know? And again, plane was flying straight, but then it's going to need to tip its nose down in order for it to land, right? And this is that angle of depression. This is that theta. Because again, an angle of depression should start at a horizontal line, and then it's the angle going downward. So let's do a little bit more labeling. So hopefully the plane to the ground, this would be like a right angle if we were measuring straight down. So we need to solve for theta, obviously, but notice how theta is on the outside of this triangle. So one way to do it, and probably the most popular way, is just to draw a second triangle. So that means that this would be another right angle. So if this side is 15,400, then the other side is 15,400. If this side is 200,000, then the top is 200,000. We're ready to label. So we've got theta here, opposite. This is our literally an opposite side. This is our right angle. That means this diagonal line is our hypotenuse. And this leftover side is our adjacent. All right, so let's focus on what we're given and what we need to solve for. We have been given adjacent, opposite. We need to solve for our theta. We do not need the hypotenuse. So that means we need to pick out our trig ratio. That's O and A. Hopefully you know that that would be your tangent. So tangent of theta is equal to your O over A, so 15,400 divided by 200,000. Now we need to solve for theta, which means we're going to switch it to the inverse. So tangent with a little -1, and this is going to be kind of squishy. Whoops. So, there you go. All right, it is calculator time, so let's grab Desmos. All right, function, tangent with a little -1, 15,400 divided by 200,000. All right, and again, we're going to make sure that we are in degree modes. We are good. So it looks like about 4.4 degrees is our theta. So that's how much that plane would like tip its nose, which makes sense. If you're in a plane, you would not want it to like dip down really fast. Uh-oh, I did overlook something. It says round to the nearest thousandths. So let's come back over here to Desmos and make sure we got everything. So if we're going to round this, we did not catch that. So 4.403 would actually be the correct answer. So let's fix that really quick. Because we're going to follow directions. 4.403 degrees. There we go. All right, let's go on to number last but not least. All right, number 4. So the clock tower at Queen's University of Charlotte is actually a Verizon cell phone tower, true story. So the clock tower is 200 feet tall. So here's our clock tower, 200 feet. A student is sitting in the grass reading a book when the clock tower chimes. So here's our person. And they're reading a book. All right, so they look up at the tower at a 63-degree angle. So if you can imagine, this person's, sitting on the grass, and then they look up to the clock tower, and this angle here that's created is 63 degrees. What is the diagonal distance from the student? Notice this is diagonal, from the student to the top of the clock tower. So we want to know this distance right here, and hopefully the clock tower would be making a 90-degree angle with the ground. And we need to round our answer to the hundredths, so 2 places. All right, so this is our theta. This is actually an angle of elevation problem because this angle is looking upwards. So here's our theta. 200 would be our opposite. Here's our right angle, so x is our hypotenuse. and this blank side is our adjacent. Again, let's focus on what we are given and what we need to solve for. We were given our opposite, we were given our theta, we need to solve for our hypotenuse, we do not need our adjacent. So that means we are doing sine of theta, and that's equal to O over H. All right, we need to solve for x, but we can't do that until we get rid of this fraction, so times x and times x. So x times the sine of 63 is equal to 200. We are going to divide because we want to get x by itself, so let's divide by sine of 63 and divide by sine of 63. So x is equal to, this is what needs to go into Desmos, so let's pull that up. So 200 divided by, and we need to do function sine of 63. So we get 224, and then we need to round this to 2 decimal places, so 465, so that means the 5 will round that 6 up to a 7. So 224.47. And that's going to be feet. And this is our final answer. All right, good luck retesting.